yeah, is of interest to us. We don't need the power function. We're going to be looking at this as though it were a derivative, either first or second, it doesn't matter. So if this were the derivative of something, the first thing I'd do would take the derivative, set it equal to 0. I'd get the zeros, which is -4 and -3. So my zeros are -4, -3. The multiplicity of -4 is what? What's the power on the factor? 1. So it's 1. Does it touch or cross? It's odd multiplicity, so it crosses. And -3 is what multiplicity? 3. Does it touch or cross? Cross. So now, if this were a first or second derivative, I would draw my number line. I would put in my critical values, -4, -3. Multiplicity 1, cross. Multiplicity 3, cross. And now I put my test point. My favorite test point is x equals 0, and it's available to me. So it's 4 times 0 plus 4, 0 plus 3 cubed, positive, positive, positive. This sucker's positive. Positive, change, negative, change, positive, and now I have it. Increasing, decreasing, increasing. If this were the first derivative, this would be maximum, this would have been a minimum. Second derivative, concave up, concave down, concave up, these would be points of inflection. Cool beans, huh? Saves you a world of pain. David, that's why I spent so much time jumping up and down in your class about multiplicity. Yeah. We spent live online last spring. So now we look at this guy. Well, this is 1/3. This is 1. So the zeros are 1/3 and 1. The multiplicity of 1/3 is 2. Touch or cross? Touch. So that means there's no change. So negative stays negative, positive stays positive. 1, what's the multiplicity? 3. Touch or cross? Cross. And again, we don't need the power function for this class. And then I'd move to my number line, put on my critical numbers, 1/3 and 1. 1/3 is multiplicity 2, so there's no change. 1 is multiplicity 3, change. And now I get to pull my test point. And look at that. I almost I was going to pull 0. 0 between 1/3 and 1? No. That's where you have to be very careful. Is make sure when you pick an interval, the test point's in that interval that you want to use. I want to use 0, but 0 is over here to the far left. I'm not used to having all positive zeros. So now, this is 0 minus 1/3 squared, 0 minus 1 cubed, positive and negative. This sucker is negative. No change, negative, change, positive. Ta-da! Now again, if this were the first derivative, negative, positive, that would be a min. If it were the second derivative, it would be an inflection point. Cool beans. Any questions? If this were the first derivative, right, this would be decreasing, decreasing, increasing, decreasing, increasing, that means it's a min. If it were an inflection point, concave down, concave up, concave down followed by concave up, 1 would be an inflection point. Does that make sense? And in college algebra course, these are just the original functions. Hopefully, you don't have to do it this way. It is never in this class my way or the highway. It really isn't. It is a slick thing that you can use that's going to save you an immense amount of time. Or you can do what I did as a student and pull a test point from each interval. You can do that too. Works the same way, just takes more time to do the problem. Works either way. Whatever makes you happy, that communicates with how you like to do problems, makes me happy. Because you get them right.